Good day everyone. We are here to present the Miller cycle, a unique thermodynamic cycle used in internal combustion engines. In this presentation, we will explain what makes the Miller cycle different, explore its history, describe its 5 key stages, and explain how it contributes to improve engine efficiency and lower emissions. So now, let's begin.
The Miller cycle was invented in 1947 by Ralph H. Miller, an engineer at Nuremberg Manufacturing Company. His goal was to improve the efficiency of internal combustion engines by modifying the valve timing. By either delaying or advancing the closing of the intake valve, the cycle achieves a lower compression ratio and higher expansion ratio. This leads to lower combustion temperature, better fuel economy, and reduced emissions. Originally used in large marine and stationary engine, the cycle found its way into passenger vehicles. Thanks to advancement, turbocharging, and valve control technologies, Mazda, for example, used the Miller cycle in their Sky Active G and Sky Active X engines. Next reporter.
The Miller cycle has the 5 main thermodynamic stages. First, intake stroke 0 to 1 isobaric, constant pressure. Second, compression stroke 1 to 2 isentropic, no heat exchange. Third, combustion 2 to 3 isochoric, constant volume. The fourth, expansion stroke 3 to 4 isentropic. Fifth, and the last one, heat rejection and exhaust 4, 5, and 1 isochoric and isobaric. Each stages contribute the overall performance and efficiency of the cycle. We'll now go through the stages one by one. Stage 1 to 2 is the isotropic compression stage. During this phase, the piston moves upward, compressing the air-fuel mixture. Unlike the Otto cycle, the Miller cycle modifies the timing of the intake valve, either closing it earlier or later. This reduces the effective compression ratio, lowering the pressure and temperature inside the cylinder. The process is adiabatic, meaning there is no heat exchange with the environment. The main goal here is to reduce engine knock and improve thermal efficiency.
Next is stage 2 to 3, isochoric heat addition, also known as the combustion phase. Here the spark plug ignites the compressed air-fuel mixture. The volume in the cylinder remains constant, but pressure and the temperature increase sharply due to combustion. This sudden release of heat energy prepares the engine for the power stroke. Since the volume doesn't change, this process is called isochoric or constant volume.
Stage 3 to 4 is the isentropic expansion or the power stroke. The high-pressure gases from combustion push the piston downward, in converting heat energy into mechanical work. Like the compression stroke, this is an adiabatic process, meaning no heat is lost, because the Miller cycles allows for a longer expansion stroke than the compression stroke. It extracts more energy from the fuel, which improves efficiency and power output.
Stage 4 to 5, we have the isochoric heat rejection. At this stage, the piston is near the bottom of the cylinder, and some of the heat from the combustion gases is released. This process happens at a constant volume representing the cooling phase before exhaust. Though it's an idealized concept in theory, it reflects how thermal energy is gradually removed from the gases before they are expelled. Finally, we move to stage 5 to 1, which is the isobaric exhaust and intake stage. Here, the piston moves upward to push the exhaust gases, then moves downward to draw in the fresh air-fuel mixture. Through this cycle, the pressure remains relatively constant, which is why it's called isobaric. Once complete, the system is ready to begin the next compression cycle.
So, to summarize, the Miller cycle is a modified version of the Otto cycle that adjusts intake valve timing to achieve better fuel efficiency and lower emissions. Its 5 stages: compression, combustion, expansion, heat rejection, and intake exhaust form a continuous, highly efficient engine process. By lowering the compression ratio and extending the expansion stroke, the Miller cycle maximizes energy use while minimizing waste and environmental impact. So, thank you for your attention, and we are now open to any questions you may have.